Circle is probably, let's say, one of the top 5 things you need to know for a calculus.
Yeah, all the calculus kids were crying.
Big deal. Okay.
What?
I'm going to give you a number of memorization quizzes on the unit circle, so just get prepared that eventually this will not be on your blue sheets and you'll have to have it memorized. All right, but so that's your background information on why we take our time on this yesterday and today. Yesterday you kind of built some background knowledge for it, right? We learned about the 30, 60, 90 triangle, correct?
Mm-hmm.
And that
3, 4, 5.
if this is A, what's the ratio for the long leg?
Oh, it's
A
root
root 3, and this would be
2A.
2A, correct. Okay. And then the coordinates of this point in the coordinate plane would be A root 3 and A, right?
Why is that? So what?
Because the x value is A root 3 out,
Oh.
A up, x, y,
Hmm.
correct? Okay. And you can put any number in there you want. I could put 2 root 3, 2, and 4, right?
Yeah.
And this would be 2 root 3 and 2.
Okay.
Right. Using real numbers. Okay. That was all multiplication, right? Because we started here, multiplied by root 3 and multiplied by 2.
Will it always start at the origin?
Yeah. What if you were given only the hypotenuse?
Easy one. So it's 0.5 and then 0.5 cubed.
Yeah, so how do I go from hypotenuse to short side?
Divide by 2.
You're now dividing by 2, right? You're going backwards. So this would be 1/2.
And then 1/2 cubed. Oh, not cubed. Times it.
Yeah, root 3 over 2.
Root 3 over 2. Wow. Sure.
Right, root 3 times 1/2.
Yeah.
Okay. So what would this point be?
Root 3 over 2, 1/2.
Okay. Cool with that? All right. In this triangle, what is the sine? No, let's go with cosine. What's the cosine of 30 degrees?
1 root 3 over 2 over 1.
Right. Yeah, root 3 over 2 over 1, which is just, correct? What does that match?
That's the x value.
They match, correct?
Probably writing this down.
Yeah? Yeah, you should. What about sine 30?
1 over 3.
Yeah. What does that match? The y value, correct. Okay. You with me? So if you understand that, you can understand the unit circle.
Will it always be that? So your sine of 30 will always equal your that length? Well,
You're going to see a pattern here. Yes, it's going to become painfully obvious. Okay, let's talk about the other special right triangle that we studied. What's it called?
45, 45.
Okay, what were the ratios? If this is A,
it is
A, what's this A?
8. That A is
Times root 2.
yes. That's what I was
Right.
gonna say.
And that came out on your sheets, I hope. So again, if I wanted this to be 3 and this was 3, this would be 3 root 2, correct? What would this point be? Right? X, Y. They match? Okay. Same question if I gave you a right triangle and the hypotenuse was 1.
You would divide the legs by root 2.
Yeah, divide by root 2. Okay? So this is 1 over root 2. Do we like denominators? All right, so what are we going to rewrite that as?
Rewrite that as root 2 over 2.
Yeah. Correct? So this would be like that, yeah?
Yeah.
Okay. Yeah, root 2 over 2 when you rewrite that as an appropriate mathematical fraction. Same question as before, what's the cosine of 45 degrees? What? Yeah, root 2, it's adjacent over hypotenuse, but we're over 1 again, right? And what did you notice? That matches. Yeah.
Is this only if it's over 1?
And the sine at 45 is also, which matches, correct. Okay.
Well, is that only when the hypotenuse is equal to 1?
Yeah. So, why did I choose 1 as the hypotenuse?
Because anything over it itself.
Because one way to remember all this is called the unit circle. If the unit circle, when you draw it on a grid, did I go too fast? Do I need to go backwards? The unit circle has a radius of 1. Okay. When we put, we're going to put all of those triangles in this one circle, and it's going to be a method for you to memorize all those values. Guess how many numbers you have to memorize?
1. Darn.
5. Root 3 over 2, 1/2, root 2 over 2, we've seen, and 0 and 1. And that will tell you the cosine and sine values and tangent for every value that we put on here for 0 to 360. It's pretty handy.
Do it.
And in fact, it'll be handy because that'll be one of the ways I teach you to memorize this stuff.
Show us how to do this.
Okay, so the first triangle we had
36
at a 30-degree angle here, correct?
Yeah.
Okay, so that's the first one we would place here.
Dang.
The coordinates of that triangle's vertex on the circle were root 3 over 2 and 1/2, correct? Just like that triangle on the right side. Okay. What is the cosine of 30? Root 3 over 2. And what's the cosine, a sine at 30? 1/2. Okay. Whoops. Nevada hunting regulations. How about that?
What? Nomadic?
Nevada. Okay. We can also put 45 on here, right? So this would be a 45-degree angle. What were my coordinates? Don't look at your notes.
Root 2 over 2.
Okay, what's the cosine of 45?
Root 2 over 2.
And the sine of 45?
Root 2 over 2.
See the pattern there starting to develop?
Yeah, dude.
And now we can start, so those are the two we used, right? So you understand how that got built in there? We can also do 60 degrees.
Oh, that's
What are these coordinates going to be?
maybe 1/2 and the other two.
Cosine 60 is 1/2. Sine 60 is 3/2. Okay? Okay, where are the 0 and 1 going to be? We have a 0 degree option, right? What is the coordinates of that point? What are the...
0 and 25.
No. It'd be, the x is 1, 0. So the cosine at 0 is 1,
Oh, sorry, radius, yep.
and the sine at 0 is 0. You'll use that information later. And then we have this as well up here. What are the coordinates?
0, 1.
0, 1. And that will be 90 degrees, right? So that would be a 90-degree angle.
Yeah.
Okay, so you've just completed quadrant 1 of the unit circle. Everything else is based on that. Okay. So let me kind of give you a couple of hints as how to, so I just encourage you to memorize quadrant 1, and the rest of it you can just figure out. Okay, so you've got like 5 values plus the angle measures, right? Here's some patterns that you might notice. 0, 1/2, 2/2, 3/2, and 1, right? So 0, 1, 2, and 3 are the numerator values, right? You can also do it this direction, 0, 1, 2, and 3, right? So cosine top to bottom, sine goes bottom to top here. Okay, there's one way to help you memorize it. Knowing that these are roots, obviously. Okay, and everything's over 2 in here. Okay, so notice that pattern. So those people that aren't here, 0, 1, 2, 3, and then make sure you got your roots on there. And then, right. And then you can do the same thing, go in this direction. Okay. All right, so that's one little method that I use to memorize this. Here's another method, it's the hand method. Okay. Does that look like the coordinate 1, right? See where my fingers match up? 0, 30, 60, or 0, 30, 45, 60, 90, right? So if do you want me to draw my hand on the board, or is this good enough?
Draw your hand.
Draw your hand.
Okay, so I have my thumb, here's my arm. Pinky, then I got my fingers. I have a really big hand. All right, so this matches. You'll like Amy, she's an artist. Okay, fine. Thanks, Toy Story. So that's 0 degrees, right? 30, 45, 60, and 90, right? That's my digits. Okay. If I fold my pinky in, correct? What's the sign at 0 degrees? 0, because there's nothing below it. Okay, let's try this. Okay, I've put my 30-degree finger in, right?
Yeah.
Okay, what's the cosine at 30?
3/2. Root 3/2.
1, 2, 3. And what's sine?
1.
1/2.
Why is it a half?
There's 1 finger for sine and 3 for cosine. Right? What about 45 degrees. Cosine, root 2 over 2. Sine, root 2 over 2.
Oh, I see. You go to the top, bottom,
Yeah. Okay, how about this one? 60 degrees. Cosine is, 1/2, and sine is root 3 over 2.
Oh, I like this.
Okay. So a student taught me this last year.
That reminds me of like a
Okay,
nine
so
times table.
very useful, Kyra Hartson. The internet's a wonderful place. Okay, and then you can do this one. The cosine is 0 at 90 degrees. Sine is 1,
So are 4 equals equal to 1?
apparently. 4 equals 1 in this time.
So, but is
Okay,
that,
so-
that is half then?
That's root 2 over 2. Because there's two fingers, and it's always root 2 over 2. So this gives you the numerator number.
Okay.
Everything else you kind of remember. But it's a kind of a useful way. You have to use your left hand. Okay.
So, top to bottom is the bottom, top, or top to bottom is the
In my hand? No, it doesn't give you the denominator, just the numerator number. So like if I did 60, I have 1/2 is the cosine at 60, right?
Yeah.
And root 3 over 2 is the sine at 60.
Oh. So whatever's on top is cosine, whatever's on bottom.
Right.
Okay.
Yeah. Okay. Oh, like this, 1 over 2?
Yeah.
Yeah, I guess you could do that.
My palm.
Root 3 over 2.
I'm just wondering.
Okay. Yeah, she didn't tell me that last year.
Yeah.
There you go. Okay, so that's the hand method for memorizing that quadrant. Okay. Okay, now let's look at the rest of the unit circle. This angle right here is 120 degrees. So from here over, 120. Here's what's really nice about this.
Just opposite. Negative.
No, because it's flipped, root 3 over 2, and then.
Same numbers,
One's negative.
you just have a negative.
It's the first negative.
Oh.
Negative 1/2 and root 3 over 2.
Yeah.
Because we're in the negative x's now, right?
Oh, yeah.
And we're still positive y though, right? So all we've done is negated the x here.
Thank you.
What about this one?
That would be
Negative root 2 over
Negative
2.
root 2 over 2 and root 2 over 2, right?
Yes, sir.
You think you could handle getting, that's 135. What about 150?
Negative root 2 and
Yeah.
So,
And then 180?
Next quadrant is the negative, and then
negative 1, 0.
Negative 1, 0. Okay. Yeah. And then if I flip this again into this quadrant, they're both negative, right?
And if you go the other one, it's just the x side, y
X
side
is
is negative.
positive.
Yeah, now x is positive, y is negative.
Dang.
All you're doing is taking these numbers and flipping them over here and putting the negatives in the right spot.
Sweet.
Now you
Okay.
have to draw the other hand over here.
I guess you could go right hand, no? Does that work?
No. But they're
I
gonna
don't-
do it
I've never
anyway.
tried that.
You can't do this negative, though, if you don't know negative.
Okay, so this quadrant is a negative and a positive. Here we're both negative, and here we're positive and a negative, right? So I could ask you, what's the cosine of 225 degrees?
And that would be negative 2 root 2.
Negative root 2 over 2 is the cosine at 225.
And then negative
Because you know that and you know it's a negative quadrant 3.
It makes a lot. Yeah.
Good. So those tell you sine and cosine,
That's awesome.
right? So I could, like I said, sine 225.
Say anything about the tangent?
That's a good question.
Oh, that's awesome.
Does anybody see how we can figure out tangent?
No. Tangent. Tangent of 30. One. Always.
Tangent of 30 degrees is not. Okay, tangent, what's the ratio for tangent?
Oh.
Opposite? Adjacent.
Oh, so you just put it.
It's the y over the x.
Easy money.
Y over x.
Easy.
So the tangent of 30 is 1/2 over root 3 over 2, which simplifies to root 3 over 3. Copy dot flip, you get 1 over root 3.
Oh.
Then you have to simplify.
Hey, did you see 2 over root 3?
No, because the 2's cancel out.
Oh.
And then simplify here to root 3 over 3. Okay, so yeah, tangent is y over x, the y over the x value. So you do tangent, could you also do cosecant, secant, and cotangent?
Probably. Yes, it can.
So like, what's the secant of 30 degrees?
Secant of 30 degrees is
2 over root 3, rewrite your fraction, right? So they're all there, only by referencing sine and cosine, which is kind of neat, right? Do you want me to show you the whole thing?
No.
No?
What do you mean by
There's an attachment in Google Classroom. Yeah, it's definitely on the other desktop. There's an attachment in Google Classroom, so that has the unit circle on it.
The whole circle?
Yeah. Whole thing. There it is. For now, all I'm asking you to memorize is the degrees. These are called radians. We don't need to worry about those until after break. Okay, so you're just memorizing the degree measures, which it's 30 plus 15 plus 15 plus 30 plus 30 plus 15 plus 15 plus 30 plus 30, right? This is 15, 15, 30, 30, the whole way around. And then your values here. So if you want that whole circle, there it is. It's attached at Google Classroom.
Oh, that's
Okay. I think it is.
oh, you like okay.
All right, one more. Then we're done. Hopefully, start to wear down. I think I cited some of these, so we may as well go with it. Okay, what if you have a point 5, negative 12?
Cosine is 5, sine is negative
Of what angle?
12.
What quadrant is that in?
That's
So, right Right.
bottom, right,
1, 2, 3, or 4?
4.
4, right? 5, negative 12.
And that would be that'd be sine of 30 degrees.
Maybe, maybe not. It's not one of the ratios.
That's
It's not. Right. This would be the triangle that's formed, correct?
well, yes.
And this would be 5, negative 12. Okay. Can you calculate the tangent? We don't know what this angle is. Sorry.
So would that be
Wrong.
a negative 10 or would it be a positive?
There's your angle. What is the tangent of theta?
360 minus that.
Opposite over.
The front. That's the answer.
It's just, so instead of isolating you like we did the last couple days to a triangle in quadrant 1, we're now expanding you into quadrant 1, 2, 3, or 4. Can I calculate the length of the hypotenuse
Yes.
with
Pythagorean.
Pythagorean theorem? Yep. And that is
144 over 25.
it's 13.
13 is
So don't forget on your calculator to parentheses negative 12 if you're doing these, because it'll give you, you need a positive there. So 25 plus 144,
169.
which is in fact
The
13. So what's the sine at theta? Angle.
Angle.
So Kato, right? Opposite hypotenuse?
Yeah.
Opposite hypotenuse.
The sine at theta equals.
So now you can get all those ratios, right?
Yeah.
So you have to place your triangle,
Oh,
figure out a hypotenuse, and work from there to get the 6.
Okay.
Okay, so, yeah. So you could do cosine and secant, cosecant. Are you okay with that? All right.
No more.
I think you're on your way to understanding this. Home homework. Nice try, though.
To A, B, 4.
Yeah, if you want to.
What's that mean?
It's a calculus free response question we did in class today. I could show it to you if you want. That's probably good. All it questions is values of functions increasing and decreasing, concavity, and sketch the graph.
just do two things.
Yes.